Cisco Catalyst Center, formerly DNAC Center, AI Network Analytics. The machine learning ML technologies can be used to identify critical issues in my network and provide a rich set of information so that I can quickly troubleshoot the issues, know their root causes, and identify the trends and insights. And we're going to get the relevant comparative perspectives. Cisco AI Network Analytics provides this value using a simple and intuitive and powerful user interface with Cisco Catalyst Center. In here we call DNAC Center, that is fully integrated with Cisco DNAC Assurance. In this lab, I will show you how to use the network insights to quickly identify common issues related to capability and throughput. And we're going to compare the APs across my enterprise, and we'll compare performance of my network to the peer networks across the KPI. I'm going to analyze assurance data between the networks, and we're going to establish the baselines relevant to my network-specific network. And lastly, we'll use the AI information to troubleshoot and resolve the network issues. Let's navigate to Hamburger menu, Assurance, find AI Network Analytics, Trends and Insights. And here we are going to find the Trends division. The AI Network Analytics uses machine learning algorithm and AI technologies to provide the trends and insights which determine the global patterns and deviations to provide a system-generated insights. The AI-driven AP comparison in the network heat maps. This compares to all APs in my network for the given month in a heat map to spot trends and gain the insights. And the AI-driven peer comparison that going to determine how my network is performing in comparison to my peer networks for a selected KPI. It also will determine how a site or building is performing compared to other sites in my network for a selected API. Here I will click the capability. I have 4 KPIs. It shows by capacity and throughput. Let's click Insight link to open a summary with a B-swarm graphic. The B-swarm charts displays the performance of the client device in my network in a 4-week time period, as shown in this figure, and the bottom of the chart represents the week 1, and the top chart represents the week 4. If there is a systematic deviation of network behavior over this period, the trends will show an errors in the chart, and each circle in the B-swarm chart represents intrasite and intersite. The intrasite is a circle represents radial, and the intrasite is the polygon represents building. And you see the size of the circle represents a number of clients in the APs. And small circle has a lower client count, and the larger circle has a higher client count. If I hover over the cursor over circle in the charts here, it's gonna show me name of the AP of the MAC address and their client count. Close this. Next, what I want to show you is the AP performance advisories. So AP performance advisories take advantage of Cisco AI network analytics. The Cisco AI network analytics is an application within the Cisco Datacenter. So it leverages the power of machine learning and machine reasoning to provide accurate insights specific to my network development. These advisories allow me to quickly troubleshoot issues. So to generate the advisories, the APs are continually analyzed over a long periods of the time using machine learning. So APs potentially provides the suboptimal client experience are grouped by the underlying reasons and suggested the improvements. Go to the AP performance advisories. So we want to see additional information with possible costs and suggested solutions. For example, the high code channel interface. I can click one of the advisories, and we could drill down further into one of the devices identified, and we'll click to the link of that device. So this page open with information specific for this selected device. Take a look. And if I wanted to explore other advisory, I could go to the bread scrub link to navigate back to the Trends and Insights page. But next, we're going to explore the network heat map. In the main menu, we're going to navigate to the assurance and AI analytics, and we'll navigate back to the network heat map. The network heat map lets me visually compare all APs in my network for a given month in a heat map to spot the trends and gain insights. I can choose to compare the APs across different KPIs and band frequencies. The insight that I gain provide information about most congested KPIs, the most congested APs, and one of within those APs, and which APs are being used. In this information allows me to further drill down to the sites or buildings in which the trends has been observed. After I have pinpointed my AP and a group of AP, I can determine how those APs are behaving historically. That's per day, or that per week, or during the entire month. So first thing you will see is the radius in my network. It shows the name of the AP and the band frequency that is used by the client, and by the icon next to the AP, you can open the the device 360 window for the AP, and we could see the AP heat map allows me to see how the AP behave historically per day or per week or during the entire month. Here the intensity of the color in the sub blocks indicates the significance. The darker color block is more significant than higher color block. So each row in the heat map represents one AP. So the AP has a daily average, or you can see the daily max. This depends on what I choose in the sort by option. This area will show the average KPI score or max KPI score for each AP during the month, and the AP with the highest score is listed on the top. I can hold my cursor over the color block in the heat map and get information such as the name and the MAC address of the AP. And do I see the band frequency and AP group, and AP location. I will see the daily average KPI score. You could still choose by average or daily max to determine the average or max KPI value for like AP during the month. After talking about the heat map, we wanted to show you the peer comparison. The peer comparison allows me to determine how my network is performing in comparison to my peer networks for a selected KPI. I could choose a KPI by the radio throughput. I could use crowd apps and radio resets. I will see the packet failure rate. I will see the interference. I will see the SSI. Let's select the day I want to compare the KPI value between my network and my peer networks. Default is going to show everything. So if I wanted to highlight the KPI value for the peer network, just highlight the peer. Next, let's talk about the network comparison. So this feature allows me to view and compare and identify the performance improvements opportunities for the objects in my network, which are the buildings, AP model families, and wireless endpoints. And this all across selected KPIs. So the default view shows the comparison of the two buildings, and I select different building, but I can also compare AP models in my network or endpoints from my network, or choose a KPI that's gonna be radio throughput, and gradient display changes that will be depending on the KPI I selected. Okay, I'll compare the Apple or Android endpoints. Average the onboarding time, average DHCP time, and AAA time. That's all I can compare. Next feature is the baselines. The Cisco AI network analytics will use the most advanced machine learning technologies to determine the baseline that is relevant to my specific network and the site. So with this information, the Cisco AI network analytics is able to determine what is normal for each network and the site for specific moment, and will have to identify the most important issues. In this lab, we're going to explore and monitor network performance using a machine learning algorithm driven the baselines. In the main menu here, we're going to navigate to the baseline. The network overview section will just show you how the total number of the building, right, and total number of controllers and onboarding issue to how many AI driven. Click the KPI. These options are onboarding time, onboarding failure, DHCP time, authentication time, and association failure. So default option is going to be the onboarding time. Now we'll notice the B-Swan charged changes for each selected KPIs. This B-Swarm charts will provide insights on how performance of the client device of my network with respect to the selected KPI. In this case, the entity in the B-Swarm chart is a building, and it is represented in the circles. So each circle in the B-Swarm chart represents the blue color. That means the circle represents a building, and I could hover the cursor over a circle in the chart and get information such as the location and the KPI SSID, WSCs, and the client count. And red color, this circle represents a building that is impacted with issues. Hover the cursor over in the chart, we're gonna get information. Same thing, the KPI location, KPI value, SSID, WC count, and the AI-driven issues. In the B-Swarm charts, then we could click a circle to show the building view. The building view will show us specific information of the site of building. I can select the KPI SSID and WC in the respective drop-down list to view the data. And I can move slider to specify a more granular time range. I can click and drag the timeline boundary line to, for example, in January 3rd. Can be more specific time range. So the charts are displayed below the timeline slider to determine how my network is performing, and the issues are triggered based on the deviation in the predicted baseline for selected KPI with a specified time period. Then hover the cursor over the charts in here, I will see the synchronized top two tips that display the duration, predicted upper and the predicted lower range to get selected points in time. The color shows us with the KPI. The red represent AI-driven issues, and the blue is showing the average KPI duration, and you see the green part shows predicted KPI. Let's click the V detail. So showing the detail to open a sideline pane with more and more the detail, all depending on the KPI I choose from the KPI chart, and the slide in pane and the color coded charts are displayed for API duration on unique clients. These Sankey charts are showed to emphasize the major flow between the flows and the device type. Let's close this. Then we're going to use a breadth scrub to return to the network overview. An alternate way to view this information is with the map view. We could click the map. That's zooming a little bit. We'll notice that each of the building is indicated by the circle on the map, and we'll click the circle. The map zooms in and shows more circles. The number inside the circle indicates the number of the buildings near that location. We're gonna click the San Francisco again. The map zooms to SFO 15. I'll hold over the circle, and here we'll see the detailed information in the building view. The next thing we'll have to see is the enhanced RM. We would like to go to AI enhanced RM. AI enhanced RM integrates the power of artificial intelligence and machine learning AI ML. The Cisco Datacenter as a service coordinates the AI enhanced RM. The Cisco Datacenter IM Control Center allows the administrators to quickly assess the health and performance of the RF coverage in enterprise level, all the way down to the single site or building level. The AI enhanced RM brings the ability to analyze historical dynamic IF data over time. Let's give a search SGC01. This site has an AI indicator alerting me to the availability of AI enhanced RM service at this site, and the enhanced RM dashboard will click it for the SGC01 opens. At the top of the page, I will see the Run RM Simulation button. This feature lets me make simulated changes to current IF profile and visualize the projected outcome against the AI enhanced RM dashlet. So we're going to run RM simulation, and we'll click create a simulation. In the simulate name, or say make some changes. Make some changes. Click advance. Under advanced here, we can make the dBs max width from 20 to 40 amp-hertz. And we'll click run simulation. And this side-by-side comparison loads, and this is a powerful tool that administrator can use to see the graphical representation of how any changes affect the network. Okay, back, cancel the simulation. Click the AI alpha profile. This is what we have. So all that in summary, the number of AP and clients that's shown in my network, we could use the IF performance, show the overall performance score, and percentage of APs with high core channel utilization, and then we see number of RM changes, which help me understand the stability of my network. IF coverage that tells us if we have enough AP in the environment and the connectivity. If the connectivity is low or AP density is low, then we need more AP in the area for coverage, for the better coverage. If connectivity is high or even AP density is low, then that means the environment is okay. I will do few APs in general. And go down where I see the RF coverage. Under here you have the RF performance. The RM changes will show the change of RM change have been made to the channel and channel width, TX power bands change, and the RFA changes that depicts the total number of RFA, tapeable and enabled radios. RM performance shows the health of my RM based on utilization, neighbor, noise, and client. And here we also see the code channel interference, how many APs are experiencing interference based on the overlapping channels for video detail, and to show exactly the number of AP impacted. Going down here, end of the page, we will see the IP coverage, AP spatial density, and power distribution. The AP spatial density represents the number of AP that are neighbors of the selected AP or at above 7 dBm. So this indicates how density placed the APs are in my infrastructure, which affects the optimal effects or value. So for channels and channel length, TX bandwidth, TX power, and so forth. I will see the power distribution. This helps me to visualize the physical coverage area being created in my environment. It also allows me to identify APs operation at a maximum power.
For the next, we want to talk about the excessive failure to connect. It is a high deviation from the baseline. In the main menu, we want to navigate to the assurance and issue and event. We're going to click the AI driven to filter the page by AI driven issues. Let's click AI driven. We're seeing 5 events. The AI driven issues mean that our AI ML algorithm has detected a deviation from norm and suspects that there is a potential anomaly in the network. This page provides a high-level overview about the impact of the issue as category. The number of issues and the locations and the number of devices is impacting. Let's click the excessive failure to connect the high deviation from baseline. If there are multiple excessive failure to connect high deviation from the baseline issue types, I see them listed, potentially representing a different locations, client counts, and event times. Let's click the issue instance. The top page reflects how much the AI driven impacts my network, and shows the information about the time and SSID, locations, the impacted sites, and the impacted clients. This easy access to this information helps me to understand and the severity of the issue, that I can indicate what to expect for those familiar with my company's Wi-Fi network. As a IT administrator, we're going to click the problem, and we're going to view the problem details. In a norm or non-AI network monitoring software, I must set the minimum and maximum thresholds. So for example, I would set the software to trigger an error notification if a percentage of failure on board session goes above the threshold. We're going to click the root cause, and we'll click the failed percentage. And here is seeing the sorts radios with a high percentage of failed onboarding attempts. Let's hover over to the mouse pointer over each one of the radios to gather some of the information about each AP. Take a look at the suggested actions to see the collection of KPI and other metrics that are provided to the user and in the other tabs. Also, I can find a recommendation on how to debug and mitigate the issues towards resolution. Earlier in the root cause tab, I saw a portable root cause and a spike in AAA and DHCP failure. So we are given related suggestions. Let's go to my assurance and issues and events. This time we're going to drop in a total radio throughput. Close this. Take a look at the drop in total radio throughput. These shows all drop in total radio throughput issues that are generated by AI algorithm using the dynamic baseline. The issue will be raised only when the throughput falls below the baseline that is created by the AI. And click the issue, I can see the details. At the top, I can see the issue details. For example, I can see the 97% drop throughput for AP in the site, and I see also the number of clients that are impacted, the time when the issue occurred, and the location. The problem details, I can see that the blue line, which is actual radio throughput, is lower than the green dynamic throughput baseline calculated by AI, and the time the drop occurs is between the 12 a.m. to 1:30. I can also provide a feedback by click the thumbs up and thumbs down icon that is associated with is that issue helpful feature, and it also allows the AI algorithm to use feedback in generating future issues. Let's click the impact. And the impact, we'll see the client detail and layer and the device breakouts. And the breakouts, here I can see the device type and the number of clients using those device types whose throughput had gone down during the time. This can give an indication of whether it is a specific device type that is being affected. And click up to application by transmit and receive. This shows the application whose throughput was affected at this time. This allows me to see if there are business critical applications or based on which I can take a further action. Click the root cause analysis. This, I see that interference and the channel utilization are very high, right? Very high. As well, during the time the radio throughput went down, right? Went down. Throughput went down. The AI algorithms correlate that KPI may have a cost issue. I can also add other KPIs graphed by using the add KPIs button here. I say the client count and see the client count is not showing anything. SNR This allows me to see if other KPI may have caused the issue, right? So, and click the suggest action is to give me suggest actions to take a resolved issue based on the KPI that the AI thinks may have caused the issue. For example, I can see suggest actions is to mitigate interference. Consider other 5G coverage to that location.